Yeah, hello guys. Thanks for joining the session. And yesterday we have discussed about IPsec, right? Today we are going to discuss about one of the important topic in the CCNA as well. Okay, CCNA security, which is NAT. Okay. Do anyone know about NAT? What is the purpose of NAT and why we are using NAT? Do anyone know about what is the purpose of NAT or why we are using NAT? Anyone? Or do you have heard about NAT, network address translation? Yeah, okay. I think you are not aware of that. Hello guys, can you hear me? I think I was speaking on mute. Guys, do you know about NAT before, or why we are using NAT and what is the purpose of NAT? Anyone?
Yeah, know about it will convert private address to public address like that, bro.
Okay, that's good. That's a one point. మనకి NAT వచ్చేసి కన్వర్టింగ్ ప్రైవేట్ ఐపీ అడ్రస్ టు పబ్లిక్ ఐపీ అడ్రస్, దట్ ఈస్ వన్ థింగ్. అండ్ ఆల్సో ఇట్ విల్ ఓకే ఇట్ విల్ కన్ ఇట్ విల్ ప్రొటెక్ట్ అవర్ ఐపీ నెట్వర్క్ యాజ్ వెల్. ఓకే, ప్రైవేట్ నెట్వర్క్. ఎందుకంటే మనం వీఆర్ గోయింగ్ ఇన్ టు ఇంటర్నెట్, రైట్? మోస్ట్లీ NAT విల్ బీ యూజ్ టు గెట్ ఇంటర్నెట్ టు అవర్ విండోస్ మిషన్స్ ఆర్ పీసీస్ ఆర్ ల్యాప్టాప్స్. ఓకే, మీరు ఇప్పుడు నెట్వర్క్ కనెక్ట్ అయ్యారు. ఓకే, మీరు ఇప్పుడు వైఫై కానీ ఏదైనా ల్యాండ్ కనెక్ట్ చేసుకున్నారు కదా మీ ల్యాప్టాప్ని. సో మీకు ఇంటర్నెట్ వస్తుంది అంటే బ్యాక్ ఎండ్లో ఈ నాట్ ప్రాసెస్ జరుగుతుంటాయి. ఎలా అంటే మీకు ఒక మీరు ఎప్పుడైతే మీరు వైఫై కానీ లేదంటే మీ ల్యాప్టాప్ వైఫై కానీ లేదంటే ఈథర్నెట్ అడాప్టర్కి కనెక్ట్ చేసినప్పుడు మీకు మీ హోమ్ రౌటర్ ఉంటుంది కదా, ఆ రౌటర్ మీకు ఒక ఐపీ అడ్రస్ అసైన్ చేస్తుంది. ఓకే, ఆ ఐపీ అడ్రస్ యూజ్ చేసుకొని మీరు ఇంటర్నెట్ కనెక్ట్ అవుతారు. మీరు ఎప్పుడైతే మీ ఆ ప్రైవేట్ ఐపీ అడ్రస్ని మీరు సపోజ్ ఫర్ సపోజ్ మీరు ఫేస్బుక్ యూస్ చేస్తున్నారు. ఓకే, ఫేస్బుక్ ట్రాఫిక్ అనేది ఎప్పుడైతే మీ హోమ్ రౌటర్కి రీచ్ అవుతుందో ఆ రౌటర్ ఏం చేస్తుందంటే ఆ రౌటరు మీ ఆ, మీ లోకల్ బ్రాడ్బ్యాండ్ ఉంటుందా, ఆ బ్రాడ్బ్యాండ్కి ఇంకొక రౌటర్ కనెక్ట్ అయి ఉంటుంది. ఆ రౌటర్ ఏం చేస్తుందంటే ఆ రౌటర్ మీ ఐపీ అడ్రస్ని బయటికి పంపించే ముందు, అంటే మీ ట్రాఫిక్ని బయటికి పంపించే ముందు అదేం చేస్తుందంటే మీ ప్రైవేట్ ఐపీ అడ్రస్ని ఆ పబ్లిక్ ఐపీ అడ్రస్ కన్వర్ట్ చేసి ఇంటర్నెట్కి సెండ్ చేస్తుంది. దానివల్ల ఏమవుతుందంటే మన ప్రైవేట్ ఐపీ అడ్రస్ ఇన్ఫర్మేషన్ బయట సైడ్ ఇంటర్నెట్లో ఉన్న వాళ్ళకి తెలియదు. ఓకే, దట్ ఈస్ ద రీజన్ ఇట్ ఈస్ నాట్ ఓన్లీ కన్వర్టింగ్ అవర్ ప్రైవేట్ ఐపీ అడ్రస్ టు పబ్లిక్ ఐపీ అడ్రస్, ఇట్ విల్ ఆల్సో కన్సర్వ్ అవర్ పబ్లిక్ నెట్వర్క్. ఓకే, and as well as we are getting, okay, because of the NAT only we are getting internet. Okay, if you are not doing NAT, okay, మనం NAT చేయలేదనుకో మన మన ఏదైతే ట్రాఫిక్ ఉందో అది పబ్లిక్లోకి వెళ్ళదన్నమాట. ఓకే, if our traffic is not going to the public we will not get the internet. Okay, the main concept of NAT is not only converting our private IP address to public IP address, it will also useful to get internet to our Windows machines or whatever the PCs that you are using. Okay, and also it will protect our IP network. Okay, it will protect our private network from the public or internet. Okay, this is the main purpose of NAT. And in the NAT we'll be having, okay, different types of NATs. So based upon okay usage, we will be having different types of NATs. So the first one is an static NAT. Okay, the first one is an static NAT. Second one is an dynamic NAT, and third one is an PAT. Okay, which will be calling as an port address translation as well, or we can also call it as a NAT overload. Okay, or NAT overload. Okay, these are the three different types of NATs that are in usage right now. So we'll discuss one by one. Okay, what is static NAT? Okay, what is static NAT means? Static NAT is a NAT where we are going to map one public IP address to the one private IP address to one public IP address. Okay, static NAT means for every private IP it needs one single public IP. మన నెట్వర్క్లో ఎన్ని సిస్టమ్స్ ఉంటే అన్ని సిస్టమ్స్కి మనకు ఒక్కొక్క పబ్లిక్ ఐపీ అడ్రస్ కావాలి. ఓకే
Bro,
Yes,
Bro, sorry for the interruption. The audio is not.
not clear, huh? Okay, okay, just a
Bro,
minute.
uh,
Yeah,
audio,
yeah,
audio, bro.
yeah, yeah, I understood. Let me share my only this screen. Can you hear me now? ఇప్పుడు వినపడుతుందా?
Yeah, bro. It's now corrected.
ఓకే, థ్యాంక్ యూ. సిఆర్ మనకి స్టాటిక్ నాట్ ఏంటి అంటే స్టాటిక్ నాట్ ఈజ్ అ నాట్ వేర్ ఇట్ నీడ్స్ ఫర్ ఎవ్రీ సింగిల్ ప్రైవేట్ ఐపీ అడ్రస్ ఇట్ నీడ్స్ వన్ పబ్లిక్ ఐపీ అడ్రస్. ఓకే, మనకి ఎలా అంటే మన మన నెట్వర్క్లో ఎన్ని ప్రైవేట్ ఐపీ అడ్రస్ ఉంటే అన్ని పబ్లిక్ ఐపీ అడ్రస్ కావాలా. దట్ టు వీ నీడ్ టు మ్యాప్ వన్ ప్రైవేట్ ఐపీ అడ్రస్ టు వన్ పబ్లిక్ ఐపీ అడ్రస్. ఓకే, సో దట్ ఈస్ వై ద స్టాటిక్ నాట్ ఈస్ వన్ టు వన్ మ్యాపింగ్. ఓకే, విల్ బీ కాలింగ్ యాజ్ అన్ వన్ టు వన్ మ్యాపింగ్. So why means for every single private IP we need one public IP. Okay, for every one private IP we need to map one private IP needs one public IP. Okay, so we need to map one private IP with the one public IP. Okay, so that is the static NAT. So how it will be like? Okay, how the traffic will be flow means, let's take you have a router. Okay, let's take you have a router and you have an any PC. Okay, let's take you have multiple PCs. Let's take three PCs. You have three PCs and your router. Okay, where you are connecting a NAT, it is connected to the cloud. Okay, which is the internet. Okay, so now what it is going to do is whenever you are sending a traffic from each PC, so it has to be map one public IP address to this. Okay, so this static NAT we have to manually mapping. Okay, we have to manually map. Let's take we'll be having 10.10.10.1 here. Okay, and here we'll be having this PC holds 10.10.10.2 and this one having 10.10.10.3. ఓకే, మనకి ఇలా మూడు పీసెస్ ఉన్నాయి. మూడు పీసెస్కి మూడు ఐపీ అడ్రసెస్ ఉన్నాయి. ఓకే, మనకి ఎప్పుడైతే వీ హ్యావ్ టు కాన్ఫిగర్ అండ్ స్టాటిక్ నెట్. ఓకే, ఇఫ్ యూ ఆర్ యూజింగ్ స్టాటిక్ నెట్ we have to configure for each ప్రైవేట్ ఏపీ వీ నీడ్ టు మ్యాప్ వన్ పబ్లిక్ ఏపీ. ఓకే, మనం ఇక్కడ ఏం చేస్తామంటే స్టాటిక్ నెట్. ఓకే, వెనెవర్ యూ రిసీవ్ ట్రాఫిక్ ఫ్రమ్ 10.10.1 జస్ట్ మ్యాప్ 203.0.110. Okay, 1. Okay, like this you have to map this. Okay, whenever you receive a traffic from 10.1 IP just map with this public AP. Okay, and at the same time you have to tell 10.10.10.2 should be mapped to 203.0.110.2. Okay, likewise you have to mention. Okay, at the same time for 10.10.10.3 203.0.110.3, like this you have to mention in your router so that whenever traffic reaches. Okay, let's take I'm just trying to reach internet from 10.1. Okay, whenever traffic comes whenever traffic comes from 10.1 and it reaches the router will check if NAT is configured or not for this. Okay, now we have already mapped, right? So this IP address will translate to IP this IP. Okay, let's take once the traffic comes here our 10.IP will be converted to 203.0.110.1 and it will send the this using this IP. Okay, using this public IP it will send the traffic to our internet. Okay, now what happens, our private IP address is safe right here. మనకి ఇక్కడ ప్రైవేట్ ఐపీ అడ్రస్ ఇక్కడ పబ్లిక్లో ఎలా ఎక్కడ కనపడట్లేదు, ఎందుకంటే వీ హ్యావ్ ట్రాన్స్లేటెడ్ దిస్ ప్రైవేట్ ఐపీ అడ్రస్ టు పబ్లిక్ ఐపీ అడ్రస్. Using this public IP address we are reaching to the internet. Okay, so this is how we have to map, and whenever the traffic reaches on the router using any of the private IP, it will check whether the translation is configured or not. If translation is configured using that whatever the public IP that we have configured, using that IP it will send the traffic out. Okay, so in this case static net, how many private IP address we have, that many public IP address we need. In this case we have only three, so we need three public IP address. If you have hundreds of systems, okay, hundreds of machines, you need hundreds of public IP address. Okay, you need 100 of public IP address and you have to map each public, okay, each private IP address to one private IP address to one public IP. Likewise, you have to map 100 private IP address to 100 public IP address, and based upon the traffic that is receiving from the private IP, it is translating and it is sending the traffic out. Okay, this is okay. This is about static NAT. Okay, static NAT is a NAT where we need one private IP to the public IP. That is the reason we are calling as an one-to-one mapping, and we have to configure it as a manually. Okay, we have to configure it as manual. Okay, this is manual. Okay, that will be burden with to our administrator to configure each, and okay, if it is 3 or 4 systems, that is fine. Okay, if you have hundreds of systems, that is burden for our okay, whoever configuring, right? So the if you are using static net, that will obviously have a burden on the administrator who are configuring. Okay, and the next one is a dynamic net. Okay, dynamic net is one to many mapping. Okay, so one to many mapping. In static net, we need one public IP, sorry, one public IP for one private IP address, right? So in this case, in the dynamic net, we are not configuring. Okay, we are not mapping one to one mapping. Okay, here we are taking some pool of IP address. Okay, in the same, okay, we'll take same situation. You have a router. Okay, you have three PCs. Okay, you have three PCs, and this router is connected to the internet. Okay, now you have connected your PCs to the router, any of the interfaces using, and it is connected to the internet. Okay, in the same way, here you are using 10.10.10.1. Okay, 10.10.10.1, and here this PC holds 10.10.10.2, and this PC holds 10.10.10.3. Okay, now we no need to map here. Okay, like static net, in the like static net, we are no longer mapping. Okay, we are just, what we are doing is we are taking one pool of IP address. Okay, let's take 203.0.110.0 slash, okay, maybe 8 or 16 or 24, based upon your requirement. You can go ahead with the okay, you can go with the subnet. Okay, we are not mapping anything. Okay, so we are having one pool of IP address in the, we are configuring a pool of IP address in the router. So whenever the traffic receives from 10.1, so it will assign any one IP address. Okay, which is available at that time. లైక్ హౌ మనకి డిహెచ్సిపి సర్వర్ ఎలా అసైన్ చేస్తుంది ఐపీ అడ్రస్, మనం ఒక పూల్ కాన్ఫిగర్ చేస్తాం. ఆ పూల్లో ఏదైతే ఐపీ అడ్రస్ అవైలబుల్ ఉంటుందో ఆ టైంకి ఆ ఐపీ అడ్రస్ని నీకు క్లయింట్కి అసైన్ చేస్తుంది కదా. ఇన్ ద సేమ్ వే, this dynamic NAT also, whenever you have received the traffic from 10.1, okay, it will check, okay, whether it is a dynamic NAT or static NAT. And if it is a dynamic NAT, it will check for the, okay, it will be checking whether any available, okay, available, okay, any IP available in this pool. If any IP available, and it will be assigning to this. Okay, let's take now, let's take this is the first traffic, right? So it is assigned 10.10.10.1 to 203.0.110.1. Okay, one IP address from this pool, and it will send the traffic out. Okay, using this IP address, this 10.1 is translated to this IP address, and using this public IP, it is sending the traffic out. Okay, it is sending the traffic out. Likewise, in the same way, when it receives 10. Okay, 2 network, it is assigning 110.2 IP. Already it has used 110.1, right? Now we no longer able to assign this IP. So now once 10.2 is once traffic receives from 10.2, it will assign next available IP in this pool, and it will be sending the traffic out. Okay, so that is the reason for one single IP we'll be having many public IP address. From this pool of IP address, it will assign one IP. Okay, that is the reason we will be calling as an one to many mapping. Okay, this is a one to many mapping. Here we no need to manually configured each and everything. Okay, like how we have did in the static, we are no longer need to map one to one. So we can use pool of IP address. From this pool, it will take one IP address for this private IP, and it will translate and it will send the traffic out. Okay, now in the same way, okay, we in the slash 24, I think we'll be having 256 IP addresses, right? So once 256 IP addresses are fully utilized, okay, if you are using, okay, if you are using multiple systems in your network, and if this pool is fully utilized, మనకి ఇక్కడ ఈ పూల్ ఫుల్గా యూటిలైజ్ అయిపోయిన తర్వాత ఇంకొక 257 సిస్టమ్ వచ్చింది అనుకో, లెట్స్ టేక్ యూ ఆర్ యూజింగ్, ఓకే, 300, ఓకే, యూ విల్ బి హ్యావింగ్ 300 systems in your network, and you have fully utilized this pool, okay. Now you are getting traffic from 10 dot 10 dot 10 dot, okay. Otherwise you are getting okay, you are getting traffic from 2, okay, 257th pc, okay, 257th pc. So now whenever you this traffic receives on this, okay, on this router, it will check the IP pool is available, okay, if any IP is available in this pool, okay. Now it is already fully utilized, okay, 256 systems are utilizing this NAT pool, and all the IP address in this pool are utilized fully. Now whenever the traffic receives from 257th PC, now we don't have any IP, right? So it will not translate, okay, it will not translate anything, and this traffic will be dropped, okay. So until unless any of the IP freed from this pool, okay, let's take now 10.1, okay, we are using 10.1 from the long time, right? Now 10 dot time has not using anything, okay. Now this IP address will be freed, okay, 203.0.1.110.1 is freed from this translation. Now this will 110.1 will be assigned to this 256 257th PC, and it will be translating this IP address, and it will be sending the traffic out, okay. Likewise this dynamic NAT will work, okay. That is the reason we are calling it as an one to many mapping, okay. So if you are using static NAT and dynamic NAT, it will be an cost effective to the companies, okay. So cost effective means uh, how many systems you will be having, that many public IP address you need, okay. You if you want a public IP address, you need to buy it from the ISPs, okay. Each public IP address will be cost some dollars, okay. So if you are using 3 or 4, that will be fine, or if you are using hundreds of systems, that will be cost effective, right? So in order to reduce the cost, okay, in order to reduce that cost, so they are came up with the port address translation, okay. So port address translation, okay, where it is it is going to translate, and also it is using an many to one mapping, okay. Many to one mapping means we'll be having only one public IP address. That public IP address will be translated to each and every private IP address, okay. So but it will distinguish the traffic, okay. It will separate the traffic, or it will distinguish the traffic based upon the port, okay, based on the port, okay. So that is the reason we are calling it as an port address translation, okay. Whenever we are receiving the traffic from, okay, let's take the same scenario here. You will be having a router. Now you will be having 3 PCs, and your router is connected to the internet, okay. Likewise it is connecting. So we are using only one public IP address here, okay. Let's take I am having only one public IP address. I am using one public IP address, 110.1. So here you are, okay, 10.10.10.1, and 10.10.10.2, 10.10.10.3, okay. So likewise you will be having the situation, right? So whenever in this port address translation, how it will work means, whenever traffic receives from 10.1, okay, it will add okay, one port here, okay. In this, let's take, you will be adding a source port as an any random port, okay. You will be use any port number 50. So whenever, okay, traffic receives from 10.1 with a port number 50, okay, it receives here. What it will do is it will also, okay, it will translate our 10.10.10.1 with port number 52 203.0.110.1, and using a port 3001. Okay, let's take, okay, this is not exact, okay, this is not exact port numbers, I'm just taking as an example. Okay, so now it is going to map, okay, it is going to map this traffic. Okay, whenever traffic receives on 10.1, it is translating using this IP, which is the port 3001. Okay, and it will be sending out. Okay, whenever the return traffic will come, right? So whenever the return traffic will come, the traffic, okay, return traffic will be having a destination port, this one, right? Three, this is a source port whenever you are sending traffic to the internet, and this will become destination port whenever traffic comes from the internet, right? So how this will be going to identify means, using this port only it is going to identify, because before, whenever you have received the traffic from 10.1 with port 50, it is translated to this, okay, IP address, which is a port, right? Using a port number, it is going to identify this traffic belongs to 10.1. Okay, so now we have received the traffic from the internet with 3001. So 3001 we have mapped with this. Okay, not mapped, it will be going to, okay, identify 3001 is a traffic which is which came from 10.1. Okay, likewise it is also translate. Okay, it will also 10 dot, okay, 10 dot 10 dot 10.2, which is the port number, let's take 51, and it will be translating to 203.0.10 dot, okay, 1, with a port number 3002, like this. Okay, it will be mapped like this, and it will be sending the traffic code. Okay, using this IP address and port, it will be sending the traffic code, and whenever the traffic receives, okay, from the internet, it will check the destination port. Okay, this port will become destination port at that time, where whenever traffic receives from the internet, and this port, okay, using this port it will identify this traffic is belongs to 10.2/51. Okay, and it is sending the traffic to here. Okay, so this is how we are using. Okay, using an port address translation, we can use only one public IP. Okay, you can use only one public IP for multiple private IP addresses, but each and every traffic will be distinguished based upon the, or each and every traffic will be, okay, each and every traffic, or each PC traffic will be identified using an port number. Okay, so that is the reason we are calling as an port address translation, or we'll calling as a NAT overload. Okay, this is one to, sorry, many to one mapping. Okay, this will greatly reduce the cost to our companies. Okay, so mostly whenever companies are going, okay, whenever company is opting for, okay, if they have multiple users, they are opting for the port address translation, so that they will only, they want to buy only one public IP address, but they will be having multiple ports based upon the traffic that is receiving from the, okay, users. They are going to map the ports. Okay, and they are going to identify the traffic based upon the port numbers. Okay, so these are the three types of NATs. Okay, static NAT, dynamic NAT, and PAT. Static is one-to-one mapping. Dynamic is many one-to-many mapping, and port address translation is many-to-one mapping. Okay, and meanwhile, do you have any questions on this? Do you have any questions on these three types of NATs before proceeding further?
Clear.
Okay, others? Yeah, these are the types of NATs based upon the IP address translation, but based upon the traffic flow. Okay, we'll also having two types of NATs, which is source NAT, or source NAT and destination NAT. Okay, so based upon the traffic flow, in the sense, whenever, okay, whenever the traffic flowing outbound. Okay, you can if you are hearing a word outbound. Okay, outbound means this is your internal network. Okay, this is your internal network where your PC is connected to the router, and your router is connected to the internet, right? So this will become your internal network, and this will become your external network. And outbound means whenever the traffic flowing from your inside network to outside network. Okay, outside network, which will be calling as an outbound traffic. Okay, outbound traffic. Okay, In that case, what we are going to use for outbound traffic, we are going to use static, okay, source NAT. Here we are going to use source NAT. Okay, so for outbound traffic we will use a source NAT, and for inbound traffic, inbound means the traffic coming from outside to our inside. Okay, that we will be calling as an inbound traffic. Inbound traffic, and for inbound traffic we will be using destination NAT. Okay, so what will happen in the source NAT and what will happen in the destination NAT means, if you are using source NAT, the source address will going to translate. Okay, we are talking about okay, in the static NAT, dynamic NAT, and PAT, we are talking about translations, right? The private IP address is going to translate to public IP address. Okay, in the source NAT and destination NAT, private IP address means we will be having the source IP and also destination IP address, right? So if you are translating okay, private IP, which IP address you are going to translate, whether it is a source IP or a destination IP. So based upon the traffic flow that we can decide. Okay, if you are sending a traffic from your internal network to outside network, so you are doing a source NAT, right? So in the source NAT, what it is going to do, it is going to translate your source IP address, source private IP address to the public IP address. Okay, how it will means, so you have a traffic. Okay, you are sending a traffic from 10.10.10.1, you are trying to reach 8.8.8.8. Okay, this is your internal. Okay, this is your okay, this is your private IP. You are pinging from 10.10.10.1 to 8.8.8. Okay, whenever this traffic reaches, okay, whenever this traffic reaches your router, so the router will check, okay, what type of, okay, what type of NAT we are going to use, and what type of translation we are going to use. Okay, so if it is a source NAT, okay, sorry, if it is a static NAT, it will check whether, okay, it will be going to check whether any public IP address is configured for the static NAT or not. Okay, and also it is coming, okay, it is going to check whether it has to be NAT source IP address or destination IP. So the traffic is coming from inside to outside, right? The traffic is coming from inside and it is going to outside, so it is going to translate source IP address. Okay, so now once it reaches here, let's take the same scenario. I have mapped, okay, 10.10.10.1 to 203.0.11, okay, 110.1. Okay, so I have, okay, statically configured this here on the router. Okay, so once this traffic reaches, what it is going to do is, this is coming from inside, right? It is going to translate our source IP here. Okay, once it reaches here, it will be translating to, okay, 203.0.110.1, and it will be reaching 8.8.8.8. Okay, so now this traffic reaches to the internet. Okay, whatever the, after translating our source IP, the traffic reaches to the internet. Okay, so now we ping, right? Okay, this is a ping request. Okay, this is ICMP echo request. Now we need to get an reply, right? So reply means this is an inbound traffic. Our traffic is coming from outbound to, okay, outside to inside. This is an inbound traffic, right? So how the traffic will come, the traffic, okay, it will reply to from 8.8.8.2. It is going to reply from 8.8.8.2, and it is going to send 203.0.110 dot, okay, 1. Okay, it is going to reply with this, and once this traffic reaches, okay, once this traffic reaches here on the router, it is going to check, okay, whether it is coming from outside or inside. Okay, it is coming from the outside, right? So it is going to change destination IP. Okay, destination NAT. Okay, it is going to do destination NAT, and already we have configured this translation, right? So it is going to map, okay, it is going to change 203.0.110.1 to 10.10.10.1. Okay, now how the traffic reaches from 8.8.8.2, it reaches to 10.10, it is translating 10.10.10.1, and whatever the traffic, okay, whatever after the translation, this traffic reaches to the system. Now we are able to reach the internet. Okay, so this is how the source NAT and destination NAT will happen. Okay, based upon the traffic flow, whether it is an outbound or inbound. So if it is an outbound, your source IP will get changed, or whether if it is an outbound, okay, inbound traffic, your destination IP address will going to change. Okay, in the NAT we are talking about IP address is going to change. Okay, IP address, private IP translated to public IP. Okay, but which IP address, whether it is a source IP or whether it is a destination IP, you are mentioning about private IP address is going to change public IP address, private IP address is going to change public IP address, but which private IP, whether it is a source NAT or whether it is a destination NAT, okay, that will define by using this. Okay, by using the traffic flow. If it is a source, okay, if it is an outbound traffic, the source IP address get changed using a source NAT, and if there is an inbound traffic, the destination IP address is changed using a destination NAT. Okay, so this is also important. Okay, whenever you see, this is also important one when considering the NAT. Okay, apart from the three types of NATs, these are also two NATs based upon the traffic flow. Okay, do you have any questions, or do you have any clarification? Do you need any clarification on this? Any question, guys? Are you able to follow me, right? అర్థమవుతుంది కదా how translation is
Yeah,
happening?
bro.
Yeah. So these are all the types of, okay, these are all the types of NATs. And if you see, okay, if you see the advantages of NAT, okay, so mainly advantages of NAT is mainly the first thing is to conserve, okay, to conserve our private IP addresses. Okay, to conserve our private IP address, we are going to use a NAT, and also to get the internet. Okay, if you are using the internet on your laptops, this NAT is the main reason. Okay, to get internet to our clients or PCs or laptops. Okay, whatever it may be. So if you are using the internet, that is the NAT is the main reason. Okay, so without doing a NAT, it will won't send your, okay, it will say the router or the firewall will not send the traffic out. Okay, if the traffic is not sending out, there will be a no internet to our, okay, PCs. So these are the main advantages here by using a NAT. Okay, and if you see the disadvantages, if you are using any switches in between, okay, in your system, it will cause some delay. Okay, because this NAT is an L4, right, and the switches and routers are L2 and L3. So to route this traffic, okay, this will cause some switching delays in your network. So that is one thing to, that is one disadvantage. Apart from that, that is the main disadvantage only. Otherwise, NAT is an good one. Okay, to protect our private network, and also to get internet to our PCs. Okay, these are the advantages that you can see. Okay, and I want to show you the lab. Okay, let me open the GNS3. Actually, I have already prepared one document. We have a simple, okay, we have one simple document and configuration of configuration as well. So this is a simple configuration, and what you have to do is you have to take, okay, in if you are using any router, okay, just take, you can take one router, okay, one PC, okay, and if you want to use any cloud or anything, okay, here in this example I'm going to use switch, and I'm going to use one more PC here. Okay, so what I'm going to do is I'm considering this as my public network, or okay, this is my outside network, and this is my inside network, and where I'm going to do a NAT translation here on the router, right? So you are taking two interfaces on the router, right? One interface which is ethernet 1/0, and I have assigned the IP address, and I'm considered this as an NAT inside, means it is our internal network. Okay, and this is Ethernet 1/1, where I have configured this IP address, public IP address, and I'm considering, okay, this is because it is connected to the outside network, right? And so that we are mentioning IP NAT outside. Okay, and that's all about interface configuration. Okay, you have to take two interface, one for inside network and one for outside network, and you have to mention which interface you are using for inside and which interface you are using for outside. Okay, and this is our actual
Hello.
uh, yes, yes.
So screen is not visible, bro.
Yeah, yeah,
Actually,
understood, understood.
GNST is not visible.
Okay, okay, good, good. uh, Actually I have shared only one window, so you're seeing the PPT, right? Lab implementation.
Yeah, yeah,
Yeah.
yeah, bro.
Actually, see here, this is a topology where I am going to use now. Okay, one, I have connected router, and for the router I have taken one interface where I have connected one PC, and to the PC I connected one switch, and to the switch I am connected to one more PC. Okay, I am considering this as an outside network, and this is an inside network. Okay, so whatever the interface that you have configured to the inside network, just configure it as an IP NAT inside, and you have no you already know how to enable interface and how to configure IP address. Okay, so you can consider that IP address as an inside IP. Okay, and also the interface as an for using for inside. Okay, and this is a Ethernet 1/1, where okay, we have configured public IP. On this interface we have to configure public IP because it is connected to our public network. Okay, and I'm considering that that interface I'm going to use for IP NAT outside. Okay, so this is interface configurations, okay, on the router, and this comes mainly, this is a picture. Okay, this is a main one step configuration to configure a static net. Okay, here what I'm saying is I'm enabling, okay, IP NAT inside means we are going to use, okay, in you are we are going to use an, okay, translating our private IP address to public IP address with source. Okay, if you are considering as a source, our source IP address is going to translate. Okay, static means we are going to, okay, we are going to assign this private IP address to the public IP address. We are configuring static IP address. Okay, this is our source IP where I am going to configure, okay, mapping, translating statically. Okay, I have mapped this 10.10.10.1 to 35.100. Okay, if you have multiple, okay, if you have multiple pieces, you have to use the same command for all those things. Okay, so in this case I am using only one PC, right? So this one, okay, one step is needed. So if you have multiple steps, so you have to map each and every IP address to one other, okay, other private IP, other public IP address. Okay, so I have taken only one PC here, so that is the reason I am using only one IP, okay, one step here. Okay, let me show that in the I have already configured in the GNS3. Let me share the GNS3 screen. Yes, I think you are seeing the GNS3 screen, right?
Yes, bro.
Yes,
Yeah,
MATLAB. Here you have to main focus on how the traffic, okay, how the IP address is translating. Okay, once this, okay, this is 10.10.10.10, which is my PC1, and I will try to ping from PC1 to PC2 to 202.14.35.10, okay, which is new public IP. So here you need to verify, okay, how the once the traffic, okay, how the traffic receiving from PC1 to router. Once the router reaches this IP traffic from 10.10.10.1, how it is going to translate. Okay, what I'm going to do is I'm going to capture the packet from here as well as here, so that we can see how it is going to translate. So first of all, let me turn on all the devices. So you can use the same configuration, or if you want, okay, if you want, you can change IP address or interfaces that needs to be connect, but configuration wise you can use the same thing. Okay, so let me open the console. Mm, yes. See here, I have already configured the things. Okay, so I'll just show you what I have configured. You can use a NAT. No. Mm. This is a inside NAT where I have configured on the Ethernet 1/0.
Bro, console is not visible.
Okay, okay, okay. I think at this time I'm going to share entire screen. You can see the console right now. Are you able to see the console?
Yeah, bro. Yeah, yeah.
Yeah. Yeah, see here, I have configured already with, okay, this IP NAT inside will be configured on Ethernet 1/0, and IP NAT outside I have configured on Ethernet 1/1, and this is a NAT translation and NAT configuration that I have using. So in this case I am using okay, static NAT, which is a using of source translation. Okay, so source translation means our source IP address is going to translate to our public IP. Okay, so before going to taking an packet capture, let me configure IP address here. This virtual PCs will not be having IP address. We can configure first, then we can start the actual taking the packet capture. So on PC1 virtual PC, if you click on show IP, no IP address will be there, right? So just configure IP 10.10.10.10 with subnet mask 255.250.0 and the default gateway 10.10.10.1. Yeah, 10.1. So let's click enter. So it is going to assign the IP, and on this one as well, check the IP. No IP, right? So just configure IP 202 dot, what is 202 14.35.10, 202 14.35.10 with subnet mask 255.255.255.0 and the gateway 202.14.35 dot, which is our, okay, 35.100 is my default gateway for this PC2. Okay, and now what I'm going to do is I'm going to ping from PC1 to PC2. Okay, and let's see, take the packet capture. I'm going to start the packet capture here, and PC1 Ethernet. Okay, yeah, fine. And I'm going to capture the packet here as well. Okay, so this packet capture will tell before translation. Okay, this packet capture will tell the before translation, and this packet capture will tell after translation. Okay, so here now you have to verify the NAT. Okay, there is show IP NAT statistics. Okay, this is the statistics. So how many IP, okay, what is whether it is a static NAT or dynamic NAT. Okay, and it will show if any of the packets are dropped or like that in the NAT statistics, and also it will show IP NAT translations. Okay, it will show whether it is going to translate or not. Okay, so as of now there are no translation, so you cannot see this outside local and outside global IP address. Okay, So you are seeing only inside a local and inside global. I will tell you what are inside local and inside global, okay, and outside local and outside global. Now what I am going to do is I am going to ping from PC1 to PC2, and we'll see the translations, okay. So use the command ping 202 dot, okay, and 14 dot 35 dot 143510, okay. Let's see if we are able to ping, right. We are able to reach our other PC, right. Now if you see here, and you have to verify, okay, if you show IP NAT statistics, so it will show here, okay. Yeah, it will show the peak translations, okay. Here we are seeing the 6, okay. How many packets it sends? 1 2 3 4 5. Where is that? Mm. And for every, okay, for everything, okay, this is outside interface, and this is our inside interface. On this number of hits is 10, means we sent 10 packets, right. We send okay, we send 5 packets, and one each for ICMP request and ICMP reply, okay. For every for every traffic we see the 2 hits, one for ICMP request and other for ICMP reply. So that's hits 10, and translated packets 10. And if you see any errors here, you cannot, okay, we are not seeing any errors, or we are not seeing any misses here, okay. If you see any translation misses, it will show it here in the misses equals to some 2 or 3 like that. But here there are no misses, so the translation works fine. And if you check the translations, okay, so we need to have real traffic, okay. So if you check the translations, see here. So here for every packet it is going to translate, okay. It is going to use, this is a inside global, okay, and this is a inside local, and this is outside local and outside local. What is inside local and inside global, and what is outside local and outside global means? Inside local means from where you are generating a traffic, okay. So now we are generating a traffic from here, right. So this will become 10.10.10 will become inside local, and the inside global will be the IP address that we are going to translate, okay. So that will be an inside global, because this is our we are going to translate our public IP to private IP address to public IP, right. So this become inside local, and this will become inside global, okay. So now the return traffic, okay, the outside global will be this, okay, the outside global will be this. And if this is going to, okay, if you have any router here and that is going to translate, that IP address will become outside global. But here we don't have any router, right. So in this case the inside global and inside local will be same IP address, okay. So here we don't have any router, we are directly connected to this PC is directly connected to switch. This switch will not having any translations, right. So this will, if you have any router, whatever the IP that it is connected here, okay, whatever the IP that is connect, whatever the IP on the interface that is connected to our the R1 router, so that will become outside global, okay. Now it is, if you don't have a switch, it is directly connected to this router, right. So in that situation, this will become both inside local and inside global IP address, okay. So outside, okay, inside local, inside global, and this will become outside local and outside global, okay. So this IP address or what it is showing in the translation table, okay. So here this is the inside global IP, and this is a inside local, and this is outside local and outside global. It is the same IP address, okay. This is how it is going to translate. And if you see the packet capture, we will be having two packet captures here, okay. See here, ping replace, okay. See here, this is receiving from 10.10.10 to, it is going to 202.14.35, okay, and we are receiving 202.14.35 to 10.10.10, okay. Means this is between this router and the internal network, okay. Now we need to check here as well, okay. In here also we'll be having, here also we'll be having the traffic. Okay, here once, okay, what I'm going to do is I will try to merge these two. Okay, so that you will get to know. Let me save this. And you got this. Okay, let me stop capturing. So if you are not stopping, it won't save, so you have to stop the capture. Stop capturing. Okay, now you can able to save this. So I'm going to save on the desktop from PC to R1, and the other one also I'm going to save. This is also from R1 to PC2. Okay, so what I'm going to do is I'm going to merge these both. Okay, I'm going to merge from PC1 to R2 to. So how can we merge two packet capture? Means take one packet capture and go on files. There is an option to merge. Okay, option to merge, and select whatever the, okay, whatever the packet capture that you need. Okay, R1 to PC2. This is the one. Okay, I'm going to merge. So here I have merged two packet captures. Okay, I have merged two packet capture. So see here, whenever we are sending a traffic from our 10.10.10.2 202.14.35.10, this IP address is translated. We are doing a source translation, right? So if you see here, we can see the ping request, two ping request. Okay, two ping request and two ping replies. Okay, two ping request means this is before translation. Okay, it is before translation, it is going from 10.10.10.2 202.14.35.10, and our 10.10.10 is translated to 202.14.35.100, and it's in the traffic out. Okay, you can see the two requests, and in the reply it is replying to 202.14.35.10 and to 202.14.35.100. Okay, from 35.10 to it comes to 35.100. Once the traffic reaches to 35.100, it is translating to 10.1. It is sending the traffic, okay, to the our actual PC. Okay, so this is how you can verify, okay, whether it is going to translate or not. If it is going to translate, you can see two ping request and two ping replies. Okay, if it is not translating, you cannot see the two ping request or replies as well. Okay, this is how you can take packet capture between your internal network and outside network, and just merge that, so that it will be easy to identify. Okay, you can see two ping request and two ping replies. Okay, so this is how you can verify the things on the, okay, NAT. Do you have any questions, or do you have any clarification do you need on this?
హలో.
Yes, yes, Pawan Sai.
అదే అదే అన్న, మీరు ఒక రౌటర్ ఒక స్విచ్ తీసుకున్నారు కదా, అదే
Hmm.
స్విచ్ ప్లేస్ లో రౌటర్ తీసుకొని
Hmm.
ఒకే రౌటర్ లో ఇన్సైడ్ అవుట్ సైడ్ ఇవ్వకుండా ఈ రెండు రౌటర్లో ఒక దాంట్లో ఇన్సైడ్ ఇంకో దాంట్లో అవుట్ సైడ్ ఇచ్చి మనం చేయొచ్చా ఇదే కాన్ఫిగరేషన్?
చెయ్యొచ్చు, చెయ్యొచ్చు. నువ్వు కావాలనుకుంటే ఇక్కడ నువ్వు ఇక్కడ రౌటర్ పెట్టుకొని ఇక్కడ ఇన్సైడ్ చేయండి, ఇక్కడ అవుట్ సైడ్ చేసుకోండి, చేయొచ్చు అట్లా.
స్విచ్ లేకపోయినా అవుద్దా? ఐ మీన్
స్విచ్ లేకపోయినా నువ్వు ఇక్కడ రౌటర్ పెట్టుకొని చేసుకోవచ్చు. దట్స్ నాట్ ఏ ప్రాబ్లం.
ఓకే.
Any other questions? Guys, do you have any questions? Or otherwise, if you don't have any questions, can feel free to drop off, and you can grab this, okay, PPT from the you are using. You have taken all the CCNA PPTs, right? The in the same website you can see this IPsec and NAT as well. You can try to grab that and try to do an IPsec and NAT labs as well. Okay. So if you have any questions, just ping me in the group. I will try to respond you. Okay. Thanks, guys. Thanks for
Yeah,
joining
thank you,
this
bro.
session. Yeah. Have a good day. Bye.